In this concept video, we're going to be discussing the sum of a sequence, which is also called a series. A finite series is simply one that has an end to it. If we did an arithmetic series for this first one, let's make it maybe 6, 10, 14, 18, and maybe 22. This on its own is a sequence. It's definitely arithmetic. We're adding the same thing in between. So a series is just 6 plus 10 plus 14 plus 18 plus 22. Note that for this to be a finite series, it has to end. You don't see any dot dot dots here. This definitely doesn't continue on to infinity. So again, the top bunch of numbers is a sequence. When we add the terms of a sequence together, that's called a series. There's a formula for the arithmetic and also the geometric. So for arithmetic series, the sum, which we just say S sub n, or the sum of the first, in this case it would be 5 terms, or however many terms there are, S sub n, is equal to n over 2 times a sub 1, or the value of the first term, plus the value of a sub n, which is the value of the last term. For the geometric, the sum of a geometric is going to be the value of the first term minus the value of the first term times r to the n power, all over 1 minus r. All one needs to do is simply enter the values in, and you've got your answer. Let's try that with the arithmetic one up here. There's 1, 2, 3, 4, 5 terms. So the sum of the first 5 terms, and I should be looking at this series actually, 6 plus 10 plus 14 plus 18 plus 22, is equal to 5, which is n, over 2. In parentheses, we need the first term, which is 6, and the last term, which is 22. If we do a little arithmetic on the right-hand side, we've got, you might not be able to see that, we've got 5 over 2, and then times 6 plus 22, which is 28. 28 divided by 2 is 14, times 5, let's see, that should be 70. So the sum of the first 5 terms should be 70. We can add this up quickly over here on the left-hand side. 16 plus 14 is 30. 18 plus 22 is 40. 40 and 30 definitely is 70. You might be saying, well, isn't it just easier to go ahead and add those up? And it is, as long as there's not too many of them. This formula is excellent if there's more than just a few. Let's move to the infinite series. So for an infinite series, these are going to be series that continue on to infinity, that have an infinite number of terms. Let me give you an example of one. We could go 27 plus, we'll go maybe 9 plus 3, and then you're going to see another plus sign, or sometimes it's a minus sign, and then the dot dot dot. This means that we need to add all of these terms up onto infinity. There's some things you want to know about infinite series though. First of all, we won't have an infinite series for, or at least a sum that exists for an arithmetic. Here's the reason why. An arithmetic sequence, or an arithmetic series, would be one where maybe you start off with 5 and then add the same thing. So the next term would be, let's just add 5, so that would be 10. Next term would be 15, and so on and so forth. When you add all these up, that's just going to approach infinity. each successive term is bigger than the other one, and so this sum right here doesn't approach really anything. It's going to approach infinity, I suppose, but we can say that the sum doesn't exist. If you think about it a different way, if you start off with maybe 16, then subtract 4 every time, we would be adding up, let's subtract 8. So that would be 8 plus 0 plus negative 8, and usually that would be written as just a minus sign there. Minus 16, the next one would be minus 24, and so on and so forth. So for either an arithmetic where d is positive or where d is negative, this sum is just going to go to negative infinity, and the sum itself is actually not going to exist. When we think about a geometric, only some geometric series will exist. Definitely no arithmetic. An actual sum will exist for only some geometric. If we look at the arithmetic, the problem with this is that in the top one, each successive term is bigger than the next one. So we need to have a situation for our geometric, just like this one up here, where each term is smaller than the next one. In other words, this series, each one of these terms of the series, it looks like it gets closer to 0. For instance, it looks like we're multiplying by 1/3 here, and so the next value would be 1, the next one would be 1/3, next one 1/9, and those values would get close to 0. This will actually have a value that it gets close to, so we could say that the infinite series, or the sum of this sequence, will exist. We want to look at r. In this case, r was 1/3, and r needs to be in between -1 and 1. So we could say that the sum of an infinite sequence, which is an infinite series for geometric, will only exist when r is in between -1 and 1. Let me give you an example of a geometric that doesn't work. So a geometric that wouldn't work would maybe be like 1 plus 2 plus 4 plus 8, and so on and so forth. So in this geometric sequence, we're just multiplying by 2 to get the next term, so r is 2. But you can see that each successive term is getting bigger and bigger and bigger. The reason why that's happening is that r is bigger than 1, so it doesn't fit this mold. So what I'll do is I'll go ahead and box this in. This is key. An infinite series, to approach some value, for it to exist, it has to be geometric, and r has to be between -1 and 1. If that's the case, then you can actually find that. The formula to find that is, we just use s is equal to a sub 1 over 1 minus r. So I'll box this in as well. That's going to be an important formula. If the sum exists, it has to be geometric, r has to be between -1 and 1, then the sum is the first term divided by 1 minus r. Let's see how that works with the one up top here. So we said that the first term was 27, and then r is 1/3. So this is 27 divided by 2/3, which is the same as multiplying by 3 over 2. And then if we did a little bit of math there, that would be 81 over 2. Or if you prefer, that could be 40.5 as well, or 40 1/2. So what would happen if we kept doing this, and I'll show you that on the calculator, we're going to take 27 plus 9 plus 3, and maybe I'll do this successively for you. So we'll do 27 plus 9, then we'll take that and we'll just add 3. Whoops, and then we'll just hit enter, and we'll go plus 1 plus 1/3 plus 1/9, and then plus 1 divided by 27 plus 1 divided by 81. All I'm doing to get this next term is multiplying each previous term by 1/3. And you can see that this sum is looks like it's approaching 40.49, and you can tell that it's going to probably get close to 40.5. But we can figure that out exactly with our formula here.